Hey all, hope we're doing well. It's a bit of a tiring time with these online lessons, I'm sure, for you guys. It's a lot of work, I know. Let's try and hang in there and do our best so that you're ready when we go back to school, which will hopefully be not too far off. I'm looking forward to getting back to school as soon as possible. I'm sure you are too, even though we probably didn't realize before that we would miss it if we didn't have to go there every day. Anyway, we're on section 5.4 now, and I'm going to do a few examples here, starting with number 3D on page 282 in your textbook. So we're putting together all of our differentiation rules and all the functions that we know, and we're going to do some combination derivatives here. So in 3D we're given g of x equals 2x squared times e to the cos 2x. And to do the derivative, we're going to need to use product rule since we have two functions here we have the product of two functions. I've underlined each one here. So derivative of the first function is 4x times the second function, e to the cos 2. Oh, sorry, let me make sure, and here's a mistake that you shouldn't make, one that I just made. Make sure that that cos 2x is clearly in the exponent. Plus, because I write so big, I need to go to the next line. The first function times the derivative of the second. So for the derivative of the second function, we know that the derivative of e to the x is e to the x. So that's this part. And then we have to do chain rule because we need to do the derivative of the exponent, which is cos 2x, which would be negative sine 2x. And then we need to do chain rule again to do the derivative of the 2x, which is 2. So let's clean this up a bit. So we have 4x. I'm really trying to write smaller, but it really just doesn't work for me. My hand naturally goes into larger and larger writing, no matter how hard I try. So it's going to have to be on two lines. Minus, I'm going to multiply this 2 in with this 2x squared, so that's 4x squared e to the cos 2x times sine 2x. So you can either leave it like that, or you may want to take the next step, which would be to factor out the greatest common factor from the two terms, which is 4x e to the cos, again, you see what I did there? Again, I didn't make this clear that it was an exponent. So very easy mistake to make. Just so you know, I always make it too. But we have to be careful because that changes the whole question. So my common factor 4x e to the cos 2x, I'm going to factor that out. And in the first term, don't forget that if I divide it by this common factor, I still have a 1 there. Don't neglect it altogether. Minus, in my second term, I have an x sine 2x. Now, why might it be useful to do this last factoring step? Can you think of a situation where it might be useful to do that step? Give you a minute to think about it. And now I'm just going to tell you, because unfortunately we're not together and I can't kill you with a million questions like I normally would to try and get the answers out of you. I missed that part. So it would be useful if we wanted to, for example, find the maximum or minimum values, because then we would make the derivative 0 and we would have to isolate x. So we would need to factor it to make it into two functions, the product of two functions, right? In the next example, we're going to do that, so you'll see how it works.